Hello everyone, welcome back to Vijay Codes It. In our previous video, we discussed what Apache Spark is. It is a unified computing engine for parallel data processing on the computer clusters. Today, we will explore the differences between Hadoop and Spark, which will help you understand why industry is moving from Hadoop to Spark. So, before we deep dive into Hadoop versus Spark, we need to understand what exactly MapReduce is, because Hadoop heavily relies on MapReduce. Let me quickly draw the diagram for you. So MapReduce follows a two-step process: a map phase, which I have shown in the green, and a reduce phase, which I have shown in the red one. So map phase splits the data and transforms it into a key value pair, and the reduce phase then aggregates the data which is split by mapper and reduces it. It would be easier to understand it with the help of an example. Let's say we have two files, and the file is like this is an apple. Apple is red in color. Let's say these two files are sitting in our HDFS, and we want to compare how many words are there in both of our files. So what will happen is the mapper will be taking this data from HDFS and it would be converting it into the key value pair, and it would look like, and the second file would be looking like. So this is what the map phase would be looking like. Once the map phase is done, then as per the diagram we can see after the mapping the shuffle takes place. So till now this data is in the mapper and it is split across the nodes. What will happen is we will bring this data together and we will compare it, and we will put the things that are similar in one reduce step. So it would be like, so this will be the output after the shuffling step. And what the reducer will be doing is it would be reducing the multiple data. Say for example here we have 2 is 1, so it would be combining those and reducing it into one single point. So after the reduce step we will be having, this is 1, so here would be 2. So this would be the output for our MapReduce, and we have gotten the count of each and every word sitting in our file system. So this is how MapReduce works. It splits the task and then it combines it in the end, which gives us parallel processing. The thing is that this output would be written in a disk, and if we want to use this output in some another program, the other MapReduce would be reading this data from the disk. This is how MapReduce works. And this allows Hadoop to process massive data sets in distributed manner. The other question would be, does Spark uses MapReduce? So no, Spark does not use MapReduce. Instead, Spark uses RDDs, which we will be looking into for the coming lectures. Now, since we know what exactly MapReduce is, now we can dive deep into the comparison of Hadoop and Spark. So let me clear some misconception about Hadoop and Spark before we deep dive into the process. So the first misconception is that Hadoop is a database, which is totally wrong. And people think this because people often use Hive and they think that they are querying a relational database, but they are actually working with files stored in the HDFS. The second misconception is that Spark is 100x faster than Hadoop. While Spark is faster than Hadoop, but it is not always 100 times faster. In most cases, it is 3 to 5 times faster. And we will cover a scenario where there is no difference between Hadoop and Spark. So these are few common misconceptions between Hadoop and Spark. So now let's dive into the comparison between Hadoop and Spark. So now let's see the differences between the data processing, how Hadoop processes the data and how Spark processes the data. So Hadoop reads the data from the HDFS, which is the file storage for Hadoop, and it then processes the data using MapReduce, which we studied in the start of the lecture. And it processes the data using the RAM. And then it stores the intermediate results in the disk. So what will happen? Let me draw it out for you. So HDFS and then the MapReduce happens, and then it stores the data in a disk. So supposingly, if we want to run another task which requires this data as an input, it would be reading from the disk again and then do the same thing. MapReduce, write it back to disk. Whereas in Spark, if we read data from HDFS, let me try it out in green. If we read data from HDFS, it will process the data. The executors of Spark will process the data and store it in the memory, in the RAM of another executor. And supposingly, if the next step wants to read the data, it will read directly from this executor and it won't be reading from the disk. So Spark basically avoids writing data to the disk. Since Spark avoids repeatedly writing and reading from the disk, it's faster. However, if the data is fitting in the RAM, so in the early lecture where I was talking about misconceptions, where people think that Spark is always faster than Hadoop, here is an example where it will be not. Say, for example, if the data is fitting in the RAM, the performance difference between Hadoop and Spark won't be as significant. So the question would be, why did Google design MapReduce in this way? So in the early 2000s, the cost price of RAM was way higher than it is today. Due to that reason, this is one of the reasons. And also Google had many other processes running on their clusters and they wanted intermediate results written to be disk so they can be processed later. Due to that reason, Hadoop is designed in this way. Now let's see the another distinguishing factor between Spark and Hadoop. So the second point is batch processing versus streaming. Hadoop is primarily built for batch data processing because in the earlier days we weren't generating that much of data, and due to that there was no need of real-time data processing. But after the internet boom, we are generating petabytes of data in matter of hour. So that is the advantage of Spark, that Spark can handle the batch processing. But It can also handle streaming data. This is what we need in today's world. This supports real-time data analytics, and hence, due to that, Spark is becoming a better option. So the next point is ease of use. Coding in Hadoop was quite difficult. Later, Hive came along, which provided SQL-like query capabilities, but it is still complex. So Hive wasn't able to solve the problem completely. But Spark made it even easier for us. Spark has both low level and high level APIs to use. And Spark allows us to code in various languages like Java, Scala, and Python. And Spark provides us high level abstractions like data frames and dataset. And if someone wants like total control of Spark, you can also use RDDs, which stands for resilient distributed datasets. So Spark doesn't only provides us with the streaming data capability, but it also is user friendly and it has multiple options for users to use too. So from the first 3 points, it seems that Spark is winning, but it's not always the case. Let's move to our next point. So the next point is of security. And yeah, this is like a major concern for us because where data is involved, we need more security. So in terms of security, Hadoop is way ahead than Spark. In Hadoop, in Hadoop, we used something called as Kerberos authentication. We also have resource management through Yarn, and we also have authorization through ACL, which is access control list. So what ACL does is, say for example, you have files in your computer, and your computer is shared by multiple people. So those files would be accessible for every other person who is using your computer. But what ACL says is you can grant permission to a person who can have the access to those files. That's what ACS does is. Spark doesn't have these security features directly, which Hadoop has, but it can leverage the security features by using HDFS for storage and Yarn for resource management. So Hadoop is leading in the security thing. Our next point is fault tolerance. Speaking in terms of fault tolerance, both systems provide fault tolerance, but in different ways. Fault tolerance in Hadoop is basically due to data replication. Let's understand what exactly data replication is. Let's say you want to process 260 MB of data. In MapReduce, one block is of 128 MB. Say we have 4 blocks. So this data will be divided into 3 blocks. 128 plus 128 plus 4. Let's say A, B, and C. So what Hadoop will do is, by default, the replication factor in Hadoop is 3. So what Hadoop will do is it will store A in this block, A in this block, and A in this block. Similarly, it will store B, 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 C, C, C. It is random. So what's the advantage of like doing data replication? Say for example, if one of the node fails, say this node is failing. Now what Hadoop will do is it would be like processing data using the remaining three nodes because we have the replicas of all this ABC present in our other nodes. Due to this way, our Hadoop is fault tolerance. How Spark provides fault tolerance is by using something called as DAG, which is directed acyclic graph. So what it does is it provides a graph-like structure. Say for example, you have like four processes. You started from step A and you went till step D. Say for example, process C is failed. So what Spark does is like Spark maintains the directed acyclic graph. So Spark knows how the process C was created. So what Spark will do is it will like create the C from scratch again. So it will use A, and from A it would create B, and from B it will create C, and hence it would recover itself from failure. This is possible because of RDDs. RDDs are immutable and it makes the recovery easier after failure, and it also makes the pipeline idempotent. So guys, just for the summary, Hadoop has been slower due to the disk-based storage, and Spark is faster due to its in-memory processing. The processing model for Hadoop is disk-based, which is MapReduce, but for Spark it's memory-based. Hadoop only supports batch processing, but Spark like gives us batch plus streaming. Hadoop is more complex to use. Hive has tried to make it easier for user by giving SQL like structure, but it is still difficult. Spark is more developer friendly. Security, Hadoop wins by far in security, but Spark can definitely take advantage of Hadoop security, and yeah, we can use the Hadoop's native security in Spark as well. Hadoop is fault tolerant with data replication, but Spark uses RDD-based recovery. So for all these reasons, in today's world, Spark is becoming more popular. And we basically Spark is a go-to framework when we want to process the data fast and in real time. That's it guys. That's it for today. In our next video, we will dive deeper into inner working of Spark and its various components. We will be looking into architecture of Spark. Until then, thank you for watching and please leave your questions in the comment section. Thank you so much.